Hi students, welcome back to my channel. In today's episode, we'll explore how to convert a recurring decimal to a fraction. In our last episode, we covered the definitions of rational numbers, which can be expressed in the form of P of Q. We also mentioned that recurring decimals can always be converted into fractions and that they are in these rational numbers. However, I haven't explained the reasoning behind this. That's the focus of today's episode. By the end of this episode, we will discover a quicker method for this kind of conversions. I've prepared 3 examples for demonstrations, and we'll use the elimination methods to solve simultaneous equations. Okay, the first one, we are going to convert 0.7 dot into fractions. Beginning, we need to assume s is equal to 0.7 dot. Okay, the meaning of 0.7 dot is actually 0.77777, okay, without n. Okay, we assume that that is equation number 1. The second step, we multiply equation 1 by 10. So the left hand side is 10x, the right hand side is 7.77777, so and so. Okay, equation 2. We try to compare these two numbers, especially the digits after the decimal points. Actually, they are the same. So if 7.777 minus 0.7777, the result will be equal to 7. Okay, so we move 9 to the right hand side. S will be equal to 7 over 9. Okay, at the end, we write the answer 0.7 dot is equal to 7 over 9. You can check answer by the calculator. They will be the same. Part B, we are going to convert 1.54 dot dot. Okay, the assumption of this will be a little bit different. Okay, assume that let s is equal to 0.54. Okay, we ignore 1. Okay, later we will add it at the end. Is equal to 0.54545454, so and so. We assume that it is equation number 1. We multiply equation number 1 by 100. Okay, log 10, I will explain why. 100 is, we multiply 100 to these numbers. The decimal points will move to the right hand side for 2 digits. So that will become 54.54545454. Okay, we need to multiply 100 in this fractions rather than 10 in the last fractions, because if we just multiply 10, it will become 5.454545. Okay, so the ending will not be 545454. Instead, it will become 4545. So we cannot eliminate the end. Okay, so in this particular questions, we need to multiply 100. Okay, so the next step, equation 2 minus equation 1, the left hand side will become 99x. Okay, the right hand side, okay, when we do the subtractions, the digits after the decimal points will disappear. So 54. Okay, s is equal to 54 over 99. We simplify the fractions by 9. Okay, so that's equal to 6 over 11. Okay, at the end, we need to add 1 to these fractions. Okay, so 1.54 dot dot, it will be equal to 1 and 6 over 11. Okay, part C, we are going to convert 0.04 dot. Okay, now try to compare the last one. The last one is 1.54 double dot. Okay, this time 0.04 dot this number is actually number can be expressed in this way. Okay, divided by 10, then the decimal point will move to the right hand side. Okay, now we assume s is equal to 0.4444. Okay, we assume this guy, we assume that that's equation number 1. This time we multiply by 10, so 10s is equal to 4.4444 and so. Okay, equation 2, that I need to move the decimal point for one place to the right. That's why I time 10 to the both sides. Okay, equation 2 minus equation 1, 9s. Okay, when you do the subtraction, it will be equal to 4. So s is equal to 4 over 9. Okay, at the end, 0.04 dot should be equal to 4 over 9 divided by 10. So it will become 4 over 90. So 2 over 45. In some situations, we don't need to do the conversion step by step. So in this slide, we are going to explore the question method to convert recurrent decimal to fractions. Okay, let's be clear. This time I won't tell you the reason. I just tell you how to do that. Okay, it is a very rare situation. Usually I will tell you everything. Okay, but in some situation we need to learn some quicker way to cut corner, to make it quick. Okay, especially in paper 2. Okay, the first one, 0.4 dot, the fractions will be equal to 4 over 9. Okay, 0.6 dot will be equal to 6 over 9. There is only one dot after the decimal points is equal to something over 9. Okay, of course you need to simplify 6 over 9 to 2 over 3. Let's do examples. There are 2 dots, so the denominator will no longer be 9, will be equal to 99. Okay, so 1.54 dot dot is equal to 1 and 99, 54 over 99. This one is equal to 3 and 18 over 99. And then you simplify the fractions divided by 9. The next one divided by 9 also. Okay, last 2 examples. There's only one dot, but the recurrent part is not right next to the decimal points. So we need to do something. Okay, we need to change it to the first 2 examples. Okay, very simple way to do that, divided by 10. You see that they are the same. Next one, 12.3 dot divided by 10. Okay, we think in this way. The next step will be very easy. The first one, 0.4 dot, is actually the first one, is equal to 4 over 9. Okay, divided by 10 times 1 over 10, that is 2 over 45. Okay, next one, 12.3 dot is equal to 12 and 3 over 9, and then time 1 over 10, that is 12 and 3 over 90, and then that's equal to 12 and 1 over 30.